Okay, so let's now look at an example here where we have a mixture, unfortunately, of sine and cosine, and they happen to all be even powered. Like, for example, sine squared x, cosine squared x. So what I need to do in a situation like this is convert them all over to sine or all over to cosine. It actually doesn't matter. Probably might change the way the type of answer you get looks, but they should be equivalent. So here I'm just going to replace cosine squared with 1 minus sine squared. And that will simplify to the integral of sine squared x dx, or sine squared, sorry, minus sine to the fourth x dx. And so what I'm going to do now is I'll work out sine squared using a reduction formula, and then I'll work out sine to the fourth using a reduction formula. And it's kind of convenient because sine to the fourth will reduce down to sine squared, so I can use my previous result again. And then we'll put everything together. We'll put everything together after that. Okay, so otherwise we would be stuck with having to do an integral of sine squared, getting an answer, having to do an integral of sine to the fourth, and we're back to going through this process if we were doing this stuff by hand. But what we're going to do is use a reduction formula instead, because it's just quicker, much quicker to do. Still not like just short. We still have some work to do, but compared to the alternative, the reduction formula is much quicker. So what we're going to do is we'll work out integral of sine squared, being the smaller one. Then we'll turn to sine to the fourth, and of course, because of how the reduction formula is set up, sine to the fourth will actually come back and involve the result we've gotten for sine squared. So let's start doing that. So first things first, integral of sine squared. So have your sine reduction formula handy. Again, not something you need to memorize. We'll provide it for you on your exams. So here we have sine to the nx dx minus is equal to minus sine to the n minus 1x cosine x over n plus n minus 1 over n, and then sine to the 2 degrees smaller. Okay, so let's set about using that now. So this will be the negative sine to the n minus 1, which in case here would be sine, cosine, all that divided by n, which is 2 in this case, and then that's plus n minus 1, 1 over 2, integral of sine to the n minus 2, which would just be dx. So that would just be negative sine x cosine x over 2 plus 1/2 x plus a constant. And so we're going to return to this piece in a few minutes, the variable part of it. We're going to put all that together with when we get to sine to the fourth. Okay, so now we're doing the integral of minus sine to the fourth x dx, so I'll just put the negative out front. And again, the negative is because of the subtraction problem here, not anything to do with the actual integral. So that'll be negative parentheses, and then we use our reduction formula. Sine minus of sine to the n minus 1, so negative sine cubed x cosine x, that's all divided by n in my formula, okay. And then plus n minus 1 over n, 3 over 4, times the integral of 2 powers smaller, sine n minus 2. 4 minus 2 be sine squared x dx. Okay. And so this is where my result from above, that sine squared, is this stuff. comes into play. So sine to the fourth, distributing my negative sign through here, would be sine cubed x cosine x over 4 minus, we're going to have 3/4 times our result here, minus sine x cosine x over 2 plus 1/2 x. Again, I'm not worrying about the plus c right now because we'll incorporate all that stuff later on. Okay. And so then that's going to be combined, so I'm just going to simplify that one step further. So distribute the negative 3/4 through. And I will have sine cubed x cosine x all over 4. Minus 3/4 times that will actually be plus 3/8 sine x cosine x. Okay. And then minus 3/4 times 1/2 will be minus 3/8 x. Okay, that's sine to the fourth. And then I'm just going to bring down my sine squared part, put it together. Put this together with the pieces here where I have like terms. Okay, so let's do that. So that's going to be minus 1/2 sine x cosine x and plus 1/2 x. And of course, don't forget about the plus c, which we'll take care of later. So putting all this together, we get 1/4 sine cubed x cosine x. We have 3/8 minus 1/2 will be minus 1/8 sine x cosine x. And in negative 3/8 plus 1/2 will be plus 1/8 x plus our constant. Okay. So now we have our integral. Our result. And again, this would have been far easier, even though it's still a fair bit of work because we had to do reduction formulas a couple times. Still way better than if we were dealing with trying to do this directly. Okay, so we certainly hope when we have trig functions like sine and cosine together that we have an odd power laying around. We really want an odd power. If they're together, we really want an odd power laying around because then we can manage it. Even powers, we have our reduction formulas, but even then, it's still a fair bit of effort to lift our way through it.